Okay, we have relationships among inscribed angles, radii, and chords. So let's get into this to see what this is all about. As always, I usually don't answer the questions unless I feel that it is beneficial, and the videos, you'll watch the videos on your own. So let's see what's going on with this one. Okay, let's go to the next part. Introduction. So as you can see, we have like a little roundabout traffic stop here, like kind of the circle. Roundabouts, if you've ever driven before, you know roundabouts can be quite confusing. Just a little off topic there. But definitions associated with circles. So I have talked about this before in another mini lesson. We'll go over it again, but if you want to have it more in depth and just the brief mini lesson about the circle, then refer back to that one. But the circle, here's the points. Here's our points on the circle. We'll explain what they are. So the radius is a line segment joining the center of the circle to any point on the circle. Always starts from the center to any other point. So let's say OA, OC, that's the radius. It's basically half of the diameter. A chord is any line segment that connects 2 points on the circle. So for an example, we have a chord EF, DG, and AC. So the diameter is also a chord passing through the center of the circle. In the diagram, it is AC, okay? The second is a line that intersects a circle in 2 places. So we have, let's see, DG right there. And then tangent is that point B over here off to the side, okay? Central circle or central angle, an angle with a vertex that lies at the center of a circle and whose ray contains the radii of the circle. Okay, so we have, where is it? Yep, we have BOC. So kind of a vertex in the circle like this. Here's this part. An arc is a part of the circle. The measure of an arc is equal to the measure of its central angle. So again, BOC like that. Inscribed angle would be the angle with a vertex that lies on a circle and whose ray contains chords of the circle. So in the figure, EAF is the inscribed angle. So where are we? EAF. That's inscribed. Circumscribed angle, an angle that a vertex that lies outside of a circle and whose rays are tangent to the circle. So that is, where are we again? G, H, and D. So that's outside the circle, just like that. The radius of a circle in tangent lines, radius is always from the center to any point on the circle. Tangent is that B over here. Okay, the questions, I will have you do these questions on your own. This is just showing from the lesson activity, you have to identify the parts and the points on the circle and what they are. Question, I'll have you answer that. Here we have a central angle and inscribed angles of a circle. We have 2 angles right here. This basically you'll have to draw the circle for the questions and it'll tell you that what you have to do for it. You'll look at the relationships of the circle and their angles. And again, this is basically what you'd be doing is identifying certain parts of the circle and what is going on with the angles. So if you answer this, and then the central angle here is just basically describing here, we have a central angle and then we have that circumscribed angle right here on this side, and they're just 2 together like this. Okay, I'll have you do these on your own. And again, in the lesson activity, you would have to identify the parts of the circle, the parts of the angle, and what they add up to be. So, like both angles would add up to be 180 degrees. So you could measure that and determine whether or not they add up to be 180 degrees. Okay, I'll have you answer this on your own. Intersecting points, it's just showing the different points located on the circle and how they intersect with each other. And kind of the same process going on over here. Same thing, I'll have you answer those on your own. Okay, so here's an example. of the radius of a circle is perpendicular to the tangent where the radius intersects with the circle. Here's showing you what that would look like as an equation or as it's written out. Here's what it would look like in a picture. Measure of the inscribed angle is half the measure of the corresponding central angle. Here's what it would look like. Here's our diagram of what it looks like. The measure of the circumscribed angle is supplementary to the measure of the corresponding central angle. That means that they'd add up to be 20 or 180 degrees. So you have like 20 degrees, it's like 160 degrees, add up to be 180 degrees total, something like that. And then for this example, 50 degrees plus 130 adds up to be 180. Okay, so the next one, when two chords intersect, the product of the length of the segment into which each chord is divided is the same. Okay, so let's see what that means. There we have it. There's the example of the line intersect. When two chords intersect, the measure of an angle between them is equal to half the sum of the measure of the arcs intercepted by that angle and the angle vertically opposite to it. Here's what it looks like. Here's what it looks like on the diagram. Okay, there you have it. Hopefully that clears it up a little bit for you. Hopefully that gives you a better understanding.